In this presentation, we look at using probability trees, and this presentation is just one example of a few where I tackle a problem using a probability tree. So here's our problem. We have two gamblers here, A and B, and they are playing each other in a tournament to win a jackpot of $6,000. The first gambler to win 5 rounds wins the tournament and the jackpot outright. Let's just be clear about some rules. Each player has an equal chance of winning each round, and also a tie is not possible. So here's the thing. The tournament is suspended after the 7th round. At this point, A has won 3 rounds and B has won 4. They agreed to divide up the jackpot between them there and then, according to how likely an outright victory would have been for both. So the question here is, how much money did A end up with? Now, here's a sort of simple approach, quick approach. Consider that A needed to win 2 more rounds, while B only needed to win 1 more. One could suppose that B was twice as likely as A to win the jackpot, and that would mean a share of $2,000 for A and $4,000 for B. Seems reasonable? Well, no, it's wrong. What we're going to do is set up a probability tree to have a look at this problem. So here's one I've made earlier. There we go. So here's our starting point. A is at 3, B is at 4. And this branch describes what would have happened if A had won the next round. A would have won. The probability of that is 50%. This branch describes the outcome where B won that next game. He would have been here. He would have won, and that would be the end of the tournament, and there's a 50% probability of that. Okay, that's why there's no more branches here. So at this point up here, going back to A's win, they would have been at 4-4. A would have to have won another game to win outright. The probability of that is 0.25. Just to be clear, that's 0.5 times 0.5. It's 50% by 50% for each branch. So we were at 4-4 here, and there was a 50% chance of B winning that game. So the probability of A winning, then B winning, would have been P equals 0.25 or 25%. So let's look at this here. There would have been a 25% chance of A winning outright, and a 75% chance of B winning outright. So the probability is therefore 75% chance of B winning, a 25% chance of A winning. So that means that A's share of the jackpot should only have been $1,500 and B getting $4,500. And that concludes our presentation.